All right, so yes, we did multiplying and dividing rational expressions and simplifying. That was the now we're talking about adding and subtracting. In my opinion, adding and subtracting isn't much more difficult. I think it's just more work. And again, it's very similar to what we used to do in school when we did adding and subtracting versus multiplying, dividing. I guess ultimately it's just this is a complete different way to do the multiplying and dividing problem, so you just have to make sure you're paying attention. I did not put this in your notes because I didn't want to make your notes more than one sheet of paper. But just to reflect really quickly, this is what we did back, again, in elementary school. When you multiply and divide, you multiply straight across. If you divide, you multiply by reciprocal, and then you multiply straight across. With adding and subtracting, you can't add or subtract until the denominators are the same. So number one, 1/3 plus 4 over 3, you can do that. That's not too bad. 1 plus 4 is 5. And it stays the same as 3. That's why you need a common denominator. If you don't have a common denominator, you need to make them common. So the first thing I want to point out with the one we just did, you add the numerators, you do not change the denominator at all. That's one of the biggest mistakes people make. And it's funny because that's the biggest mistake people make back in elementary school when you learn this. It's also the biggest mistake they do in this chapter. So make sure your denominator, the whole reason you got a common denominator is because they don't change at all. If they don't have a common denominator, you need to make them common. So I can make them both a 4 if I multiply this one by 2. Remember, if you multiply the denominator by 2, you have to multiply the numerator by 2. So this ends up being 3 over 4 plus 12 over 4. Now, if you never knew this, you literally just did the opposite of reducing your fraction. So if you take that 12 over 4 and reduce it, it'd be 6 over 2. Actually, it'd be 3 over 1, but see it over there. Now that your denominator is the same, now you can add your numerators. 15 over the common denominator, that is 4. Again, the denominator didn't change. And the biggest thing I want to point out with this one is make sure you multiply the top and the bottom by the same thing. So today, we're not going to be multiplying by 2. We'll be multiplying by x plus 2 or something like that. But you have to do the numerator and denominator need to be multiplied by the same. Number 3, this you have to multiply. I can't make the 5 into a 3. I can't make the 3 into a 5. So I'm going to multiply the 3 by 5 to get 15 and to multiply the 5 by 3. But again, the numerator and denominator. 15. 3 times 5 is 15. Now we can add the numerators. 26 over, and then 15 and 15 is 15 because it's a common denominator. So again, I'm hoping that's something that's like, yes, obviously we've done this before. I actually would be genuinely curious to give you guys those problems and see how many people would struggle with that before I went over it. But the truth is it doesn't matter because now that I went over it, I'm hoping you guys all remember what those are and how to do those problems. So again, the reason I'm doing that is because, like I said yesterday, the math rules don't change at all. So now instead of having those normal ones, now we're going to have problems that look like this. And we have to get common denominators. So if you look at number 7, we're not going to do it right now, but it does have a common denominator, x plus 2 and x plus 2. So that one's already sitting pretty good. Number 8's going to get a little bit different. But before I do this, the first thing I want to make sure, and actually I did before I had some that were monomials that are a little bit different. So you probably won't remember when you get to pre-calculus, but if you do remember, we didn't do the monomials because these are more common. But finding the least common multiple, which is finding the common denominator, when the problem's are already factored. So again, I like to start with these kind of baby steps. So these are already factored for you. As you can imagine, we're going to get to problems that you'll have to factor to get to this step. So the way I do this, and I've had this set up differently, but the easiest way I do is I look at both of these and I ask myself, what does the first one have that the second one doesn't? Well, the first one has an x plus 3, so the second one also has to have an x plus 3. So x plus 4, I need to add an x plus 3 to that. And I guess I should say, sorry, mind my wordage. When I say add, I meant like add it to the paper. Technically, you're multiplying those. You probably didn't notice, but just in case. So then I ask myself the same thing about the second one. Is there anything that this second one has? but the first one doesn't. Now there's no. The answer is no for this one. They both have an x plus 4. They both have an x plus 3. That's x plus 4 and x plus 3. If you want to multiply those out, you most definitely can. Recommend it. Actually, we'll multiply the numerators because we can combine like terms. We'll talk about that once we get there. As far as the denominators, just leave them like that is going to be the easiest. Again, if you actually want to multiply, that's up to you. There are going to be problems that it starts to get pretty long if you attempt that. So moving on to number 2, again, same thing. What does this group have that the other one doesn't? Well, they both have an x minus 2. That's nice. But the one on the left has an x plus 7. So this one also needs an x plus 7. Same thing with the other one. We need them to match. So now what does this one on the right have that the first one doesn't? Well, now they both have an x minus 2. They both have an x plus 7. So that's great. But this one also has an x minus 4. So this one needs an x minus 4. So your least common multiple is x minus 2 times x minus 4 times x plus 7. And I also should add, it doesn't matter which order you put those in, whatever order you want to do. I just try to stay with both my fractions once we get there. But that's it. That's the least common multiple. Now, even when you get to one like number 3, for 3, they both have the x plus 5. That's really easy. The one on the left has an x. So I need this one multiplied by x. The one on the right has a 3, and the one on the left doesn't. So I need to multiply that one by 3. So this one, 3x times x plus 5. Again, it doesn't matter what order you put those in or how you put parentheses. That's fine. But that is your least common multiple. Now, I didn't put this one on here, and maybe I should have. But if you had one that was the least common multiple between x plus 6 and x minus 4, so they didn't have anything in common, don't make that harder than it is. You just have to have a match. So this one needs an x minus 4. This one needs an x plus 6. Now they do match. So even if they don't have anything in common, that's okay. So now going into the ones where you have to factor first. Now, again, just like yesterday, I'm not going to give you anything that's crazy to factor. At the very most, I will give you a trinomial to factor that does not have a leading coefficient. Number 7, factor everything first. So x squared minus 9 is x plus 3 is x minus 3. The same thing we just got done doing. So make them match. They both have an x plus 3. This one needs an x minus 3. So now they both match. That is our least common multiple, which is going to be our common denominator for our purposes. Number 8, same thing. Factors of 10 have to be 7 are 2 and 5. Again, if you need to do your x factoring to make sure you can, I still very much recommend double checking. 2 times 5 is 10. 2 plus 5 is 7. Factors of negative 6 that add up to be negative 1. That is x minus 3 times x plus 2, I think. Double check. 2 times negative 3 is negative 6. Negative 3 plus 2 is negative 1. Perfect. I'm probably doing that to give you an example, but no, I actually wanted to check that. Sometimes I miss those. So again, now from here, we know they both have an x plus 2. That's awesome. This one has an x plus 5, so this one needs 1. This one has an x minus 3, so this one needs 1. Now, they both match. They both have an x minus 3. They both have an x plus 2. They both have an x plus 5. And this is why, I should have said this earlier, this is why I tell you, you don't have to multiply those out, because if you multiply all those together, it's not hard. It would just take forever. You'd have to multiply like the first 2 together, and then take that answer that's now a trinomial, and then multiply it by this one. Again, you're more than welcome to do that. I wouldn't recommend it. Go ahead and do number 6 on your own real quick. For time purposes, I kind of want to skip this one, but I think this, in my opinion, this is the hardest part of the day, or the biggest part, the key thing you need to know. So go ahead and do this one on your own, and then we'll move on to the next couple problems. All right, so that's my answer up there. X minus 5 times x plus 4 times x plus 3. Again, the order doesn't matter at all. Kind of all depends on how you write it up there. Now, the last thing I'll tell you before we start on the next thing is remember what I talked about over here on the second one. Well, we did it on the third one as well. If you multiply the bottom by something, you have to multiply the top by the same thing. So what we're eventually going to do, these will be our two denominators. To make them match, we have to multiply by the x plus 4 and the x minus 5, but then you'll have to multiply the numerator by the x plus 4 and the other numerator by x minus 5. So if that doesn't make sense, we'll get into examples that'll make it a little bit more clear, but I thought maybe kind of introducing that before we start some of these, I think would probably help. The next thing we're going to do is adding. We're going to get into adding rational expressions, very similar to multiplying and dividing. Remember how I said, if you know how to multiply, then dividing is pretty much the same, because you just make it multiply by reciprocal, and then it is multiplying. This is also very similar with adding and subtracting. Once we get into subtracting, I'll show you one step that you do that changes it to adding, and then you do the same thing as all these. So once you know adding, you're pretty set. So one big thing is only factor the denominators. If you want to factor out the numerators, you can. It's just going to be a waste of time because you're going to factor them, and then you're going to have to go back and multiply them in about the next step. So only focus on factoring the denominators, so we can get common denominators. The numerators, though, remember the denominators, I said you don't have to multiply them together. Even with multiplying, you don't have to actually multiply them together. Your numerators with adding and subtracting, you will want to. It's going to be pretty obvious because we're going to combine like terms. So they already have a little easier. They already have common denominators. Hold on, let me see what this box says. Oh yes, real quick. I know I wrote this in here, but it was more to remind me than to remind you guys. You cannot cross reduce with adding and subtracting. That's only with multiplying. So if you would have noticed, like if there would have been an x plus 2, the numerator up here, you can't cross those out. That's only with adding, with multiplying and dividing. So note of that. Okay, sorry. 7, we already have a common denominator of x plus 2. Since you already have a common denominator, one thing I've done in the past, wherever you're going to put your answer, I put my common denominator as x plus 2. Because before you do any adding and subtracting, if that is your common denominator, that means that's going to be the denominator of your answer. Common denominators, now we can add our numerators together. And don't write this stuff down. I mean, you can, but I would not. We just add our numerators together now. Now, the reason I say don't write it down is because literally I just look at this, and that's where I add them together. And when you add, it's just combining like terms. So there is no other x squared. We start with my highest exponent. Technically, it's your highest degree, but for our purposes, that's highest exponent. Then we have 6x and 2x. That is 8x. And then we have a minus 5. Technically, yes, there are still excluded values on this. We're not going to worry about it for these. That's your answer. Find common denominators. But now you know, I guess I should say, now you know how to find your common denominators. And now you know what to do once they have common denominators. So if we put together that question and the ones we just did, it's pretty close to how we're going to do these. The other thing I will say, when you take a test or a quiz, if you need more paper, please use it. I made my worksheet for this lesson, and I put it on, and it has 6 questions, and I put a lot of space, way more than I thought I needed. And then when I made my answer key, I actually used a lot of that space. So don't be scared to use extra space if you need it. Definitely helps to stay organized. So number 8, we need to, we don't have common to them. The first one's already factored, which I will rewrite. I leave myself some space and put my plus. My next one, when you factors of 2 that add up to be negative, x minus 1 and x minus 2. Didn't change yet. But again, this is one of those steps that I have some people that try to skip it, and they try to just like write it up here x minus 1, x minus 2, and they tried to do everything. Again, if you want to do that, and that's up to you, I think it's very, very beneficial to rewrite everything, give yourself some space, be organized. Because again, this is one of those problems, but I think the hardest part is it just gets kind of busy. Okay, so all we did so far is we factored that denominator. From here, here's the math. Well, this one has an x minus 1 and an x minus 2. This one just has an x minus 1. So this is the least common multiple we just talked about. So if this one has an x minus 1, they both have that, we're good. This one needs an x minus 2. This is what I was talking about. If you put that in the denominator, you also have to put that in your numerator. You have to. I can say, well, this multiply you want, and then that's all you have to do this problem. That does not work. That is not going to help you. The second fraction, it already has the x minus 1, x minus 2, so we're before I move on, that will be the denominator in your answer. X minus 1 times x minus 2. That, wherever you put your answer, that's going to be the denominator. So your numerator for this one, first off, we do need to multiply this because again, we need to combine like terms. You can't combine like terms if you haven't multiplied. So x squared minus 2x. 2x minus 1. I will go ahead and rewrite this. This is where it's a little bit of a pain because I know you're rewriting the same thing 1,000 times. I used to have a little shortcut where I wouldn't make students do that, but then people started getting lost on where they were and what things were what. So I just want you guys to do that. So last but not least, now we have everything multiplied. So our denominator is going to be x minus 1 times x minus 2. Doesn't matter where you put the, or what order you put that in. Our numerator, we have x squared. This is an interesting one. Okay. That's okay. Whatever. I missed this. We have minus 2x plus 2x is 0x, so we don't write that one down. Then we have minus 1. That's your answer. Here's the deal, and this is what I mean when I went through and I tried to take these out. Hypothetically speaking, you should always check to see if your answer can reduce or simplify. I don't want you to do that. It takes a lot more time to do that, and yes, I should have you do that because it is good practice to check your work. It's just a hard one for me where you go through this whole problem where you do a lot of factoring, you do a lot of multiplying, you combine your like terms, and then at the end you think you're done and you still have to do that. So for instance, this one, my numerator is actually x plus 1 times x minus 1 if you factor. The x minus 1 is in the numerator and the denominator, so they cancel, so you could simplify this answer. I do not, I mean, if you want to do that, you can. I'm not expecting you to. Honestly, on the test, I'm going to try not to have any of those on there. Because like I said yesterday, I want this chapter to be kind of the basics of rational expressions. I don't want to give you like the super hard questions that you guys can do later and you'll forget about anyways by the time you get to pre-calculus. So just leave your answer like that is fine. Go ahead and do this one on your own. Keep in mind that x minus 3 squared is just x minus 3 times x minus 3. Hopefully you remember that, but just in case. Go and do number 11 on your own. Like I said, once you know how to do that on your own, the subtraction problems aren't much different. All right. So my answer's up there. A couple quick things with this one that might help a little bit, or at least helps me. When I do this problem here, when I multiply these binomials, again, you know me, I'm not good at mental math, and so I used to do this. I write it out twice, and then I combine these like terms. You can do however you want, but I don't combine these like terms because I just do it in this step when I'm going to combine with this one anyway. So negative 9x plus 3x minus 7x. That's why I have the negative 13. However, you can also combine these into negative 4x and then combine it. It doesn't make any difference. That's one thing. One other thing you can do or not, it's completely up to you. If it's shorter to write down, if you ever have x minus 3 times x minus 3, if you want to write it as x minus 3 squared, that's totally fine. You do not have to by any means, but that's a little bit of a shorter way to write it since you have to write it down 10 times. That's up to you. Again, if you'd rather, you can multiply everything together, but I think that probably is worse. So moving on to subtraction. Now again, just like I said, it's similar to multiplying and dividing. Multiplying and dividing are the exact same problem outside of one step. Remember, when you multiply, you just multiply straight across. With dividing, the first thing you do is you multiply by reciprocal, and then you multiply straight across. With adding and subtracting, they're similar. The way I would do this, and I'm sure there's other ways that are, in my opinion, way worse. Side of a parenthesis, a lot of times you take that negative and you distribute it to all of them. So it's negative 5x squared plus 4x minus 10. It just changes all the signs. That's what we're going to do with this one, and we're going to change that minus to a plus. I personally, I don't like minuses. I feel like they're a huge pain. So the first thing I would do is I would change that to a plus. And what that does is that changes all the signs just in your numerator. Don't touch your denominator. So maybe that's what makes this one hard. Don't touch your denominator. In your numerator, everything changes to its opposite sign. So 5 changes to negative, negative 4 or minus 4 changes to positive, and this plus 10 changes to a minus 10. It's the exact same problems we just did. So these do have the same denominator, so that's kind of nice. And now we combine our like terms. Negative 5x squared, there is no squares, so that's that. The only thing, now or nothing can combine with that. 2x, 4x, now it's a plus 4x, so that's 6x, and 3 minus 10. Now it's a minus, 3 minus 10 is negative 7. That's how I do that problem. And any subtraction problem, that's how I do it. Everything else is the exact same. Once you change those signs, and again, honestly, in my opinion, the hardest part is remembering to do it. To a plus, and again, you only change the signs of your numerator. Remember when we talked about slope? When we talked about how you could have the negative with the numerator, you'd have the negative with the denominator, but you could not have it with both. That's the same concept. You can either do it to the numerator or the denominator, but not both. But spoiler alert, if you do it with the denominator, it's going to make this one way harder. So let me get rid of this. And we only have about 5 minutes left, so I'll probably only do like 1 or 2 of these. But again, like I said, don't make these harder than they are. I'm not saying they're easy, but they're not any more difficult than the adding problem. So I change this to plus. My 2 changes to a negative. My 5 changes to a plus. And then you factor. Now, the nice thing about these two is at first glance, they might not look factored, but they are factored. Now, if you're someone like me, I'm going to double check that and then triple check that because it seems weird to have denominators that you don't factor, but that's the case on this one. However, once you've done that, or once you know it's not factored, you do it the same as all the other ones. So this one has a 2x plus 5, so this one needs a 2x plus 5 in the numerator and the denominator. So now they almost match, but the first one doesn't have a 4x plus 3, so I need to put a 4x plus 3. Numerator and denominator. So, multiply out your denominators. I hope that saves you a little bit of time. Your numerator, so my numerator 4x times 3x is 12x squared. I probably should put these in parentheses just to make sure. 4x times -1 is -4x. 3 times 3x is 9x, and then 3 times -1 is -3. And again, if you want to combine your like terms, the -4 and the 9, you totally can. For me, I might as well wait, and I'll combine all of them at the same time. Then your next one, just pay attention to your signs. -2x times +2x is -4x squared. -2x times 5 is -10x. +5 times 2x is +10x. And +5 times +5 is +25. So, and again, this is why I think these problems are difficult. It's really not bad, but there's so much going on, and there's so much writing, and there's so much staying organized, and there's so many little opportunities to accidentally miss a negative. There's a lot going on with these problems. So when you do these, try to take your time, try to stay organized, double check things, go slowly, use a calculator. My denominator is 4x plus 3 times 2x plus 5. Then I have 12x squared minus 4x squared. So that's going to be 8x squared. Now I have -4x plus 9x minus 10x plus 10x. Well, the good news is the -10 plus 10 cancel. So -4x plus 9 is plus 5x. And then the last one we have -3 plus 25 is +22. That is your answer. I will never say these problems are easy, but I will say, in my opinion, the hardest part really isn't the math as much as staying organized and making sure you're going through stuff, combine your like terms correctly, pay attention to positives and negatives. Because yes, I mean, there is a lot of math in this. We're doing a lot of multiplying, we're doing a lot of making sure numerators and denominators have the same stuff. There's a lot of rules going on. But ultimately, a lot of those rules we've done before. And there's so much going on, there's so much writing, and there's a lot to stay organized with. That's the last one I'll do because we only have about 2 minutes left anyways. If you have any questions, let me know. There is an exit ticket. There is the worksheet. Make sure you're looking at those. The good news is I'm hopefully going to make this test shorter than the other ones because these problems take longer than some of the other ones.